Hello,
Vaish, how are you?
I'm good. How are you?
Good. Forgive my mask. I'm in an airport.
Oh,
Okay. So, um, I thought, let's see. Here, you can see. You can see what I'm going through. Okay.
we didn't have to do this if
Oh no, no,
you.
no, 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 no. I have a long, it's perfect, actually. It's perfect. So, and you
Okay,
have a test tomorrow, don't you?
I do, yeah.
Okay. So, off we go. And I still have the sequences and series dealio, right?
Yeah.
Okay. Let me move that. Okay, and I think we had left off at let's see, number 7. We finished number 6. Yeah. So let me get that. How was school today?
It was pretty decent.
Yeah,
Yeah,
most decent, I guess.
yeah.
Oh, look,
Same old.
I'm gonna be hip like you. Ready? Look at that. Oh, wait. Now it's all mess. It's all askew. Okay, hold on. I can't be cool like you. Clearly. All right.
Okay, not all of us can be cool.
Well, listen, it's a curse for you. I understand.
Yeah.
All right. So let's get all this nonsense up here. And maybe we are now ready to go. No, I don't want that. I want this. Okay. All right. So angles of a pentagon, right?
hmm
So then, do you know how to find the sum of the measures of the angles in any polygon?
Is it n minus 1 times 180?
N minus 2
2?
times 180. Yeah, because just a quick sketch, just like here's the deal. It's just breaking it up into triangles, right?
Yeah.
So 1, 2, 3. So here's a pentagon, right?
hmm
So from any vertex, what it doesn't matter, I'll do this one, right? I can only get 1, 2, 3 triangles. So that's why it's n minus 2. And it works out that way
Right.
for every polygon. So, and so 3 times 180 is 540, whatever.
Okay. So then we can do like x minus 2d plus x minus d plus x plus, and then you can do that is equal to 540, and
Yeah.
then all the like d's will cancel out.
You got that right, Jack? Well, sort of.
Yeah.
Wait, x plus d, or no, x.
Wait, x minus. Okay, so there's 5 angles, right?
Right.
So we can just say the middle one is x, so the lower ones can be x minus 2d and then x minus d.
You're too smart for me. You're absolutely way too smart for me. My God, what a train wreck I am. All right. X is the angle, or X is the middle angle, right?
Yeah.
And then X plus D. Now we have to be careful when we get the answer though, right?
hmm
Because it's asking for, oh, well, no, we don't. X minus D, X minus 2D equals 540.
Mhm.
So 1, 2, 3, 4. I guess I didn't have to do that, did I? 5x equals 540.
Mhm.
X equals 108. Now, wait a second. We don't know what the common difference is, though.
Mm. Yeah.
I don't know. I think you might be right. Because I did this. Let's see what happens. I really like your method. I hope you're right.
I learned it from my dad.
Oh, really?
Yeah.
I really like your dad's method. You should have totally taken credit for it. How would I ever know?
Yeah, it was actually I taught it to my dad actually.
That's what I thought I heard you say.
Yeah.
5x plus, right? 5x plus 3, 6, 10d equals 540, right?
Mhm.
5 times x plus 2d equals 540. X plus 2d equals 108, right?
Mhm.
Factor out of 2, then it's 54 minus d. I swear I did this before and somehow. Oh, we'll see. Yes, look at this. Yeah, it has to be 108. You're right, because 108 minus 2d is the smallest angle. So your method is better. My method sucks. Good job. Very nice, Dad. Like you did that question with him already?
No, like we
Just a
came
general
across like
thing.
a couple of problems
Yeah,
that use that method.
yeah. Good for you. That's awesome.
Thank you.
Oh, I don't know if it's going to work again. Do you? I'm not sure.
I don't
Arithmetic
know.
sequence. The angle of the largest sector is twice the angle of the smallest sector. Find the size of the angle of the smallest sector. Okay. So we know the area is pi r squared. Am I right? And we know that the area of a sector is 1/2. Do you remember this, or you want me to put it up here?
I don't remember
It's
that.
where did it go? Oh, here it is. Area equals 1/2 theta r squared.
Mm.
Theta's in radians. Okay, so if what do we have to find the angle of the smallest sector?
Yeah.
So that means that um, one half r squared theta, right,
Mm.
is u sub 1. Do you agree? And u sub 12 is equal to 1/2 r squared 2 theta. Is that fair? Right? Because it's double.
Mhm.
Okay. And so um, 1/2 r squared theta plus 1/2 r squared theta plus d, right? Plus for the second one,
Isn't it 2 theta? For the second one?
no, it's into 12 circles, 12 sectors, right? And
Oh, for the, I was thinking about the 12
yeah.
term. Yeah, sorry, yeah.
So what, okay, the area increases. Oh, I'm so stupid. We have the first and the last term, don't we? This is use of 12, right? And so the sum, right, is equal to n/2 times u sub 1 plus u sub n, right?
Mhm.
So the sum of the first 12 is equal to 12/2 is 6 times 1/2, oops, r squared theta plus 1/2 r squared 2 theta, right?
Mhm.
And we know this is pi r squared, right? Okay, so this is, we can factor out a 1/2 r squared. Would you agree?
Yeah.
So that would be 6 times 1/2 r squared times theta plus 2 theta, right?
Mhm.
How pi
5/3.
equals,
Oh.
oh, no. So this is 6 times 1/2 is 3 times 3 theta. Pi equals 9 theta. Pi over 9 equals theta. You don't look happy.
Wait, how'd you get the 3 times 3 theta?
Okay, well, 6 times 1/2
Yeah, that's
is
3.
3. Theta plus 2 theta.
Oh. Yeah. Okay, yeah, I get it.
You can't see, but I'm laughing under the mask. Wait a second, hold on. Oh, God, I just messed up my things. I'm so lame. Golly gee. I have to stop trying such trickery. Okay. They're going to toss me right out of the airport, by golly. How am I doing? Doing okay?
Yeah.
Doing all right there? All right. I want to be the legit white guy in the airport.
So then theta is,
Pi over 9.
yeah, so 20 degrees.
They said in radians. Didn't they? They don't specify.
Oh, yeah.
So don't do it, right?
Wait, could
Like,
you go back for 1 second? Don't we? Oh, wait, never mind.
all good?
Yeah.
It is 20 degrees,
Yeah.
but all right. Oh, so u sub u sub 5 minus u sub 4 equals 576. Yes.
Mm-hmm.
And u sub 2 minus u sub 1 equals 9.
9.
So that means that u sub 1 Here, let me just do all these then. U sub 5 is equal to U sub 1 R to the 4th, right?
Yeah, yeah.
U sub 4 is U sub 1 R cubed.
Yeah.
U sub 2 is equal to U sub 1 R. And U sub 1 equals U sub 1, right?
Mhm.
So we have U4, I'm sorry, U sub 1 R to the 4th minus U sub 1 R cubed equals 576.
Mhm.
And so do you agree then that R cubed times U sub 1 R minus U sub 1 equals 576?
Yeah.
Okay, and we also know that U sub 1 R minus U sub 1 equals 9, right? So what we have is I didn't point it out, but we have a system of equations, don't we?
Yeah.
So and what are we solving for? Oh, the sum of the first
sum of
5
the first.
terms. So all we need is R.
Mhm.
No, yeah, because U sub 1 is U sub 1, right?
Yeah.
Okay, so let's see, what can we do here? U sub 1 times R minus 1 equals 9. You with me? I just factored out a U sub 1.
Oh. Oh.
Right?
Yeah. Yeah. I got it. Got it.
Oh, I know what I forgot to do. I can factor out a U sub 1, can't I? Up here.
I mean, don't you just know that that middle part is equal to 9?
Right?
I mean, couldn't you keep the U1 in there and just because you know that whole thing's equal to 9?
What whole thing is equal to 9?
U sub 1 times R minus U sub 1 is equal to 9.
Oh, yeah, I guess we could. I see where I went was I was thinking substitution, and then I saw, sorry. Yeah. I was thinking substitution.
Mhm.
So then we're in business, aren't we?
Yeah.
Okay, so whatevs. So now, well, no, we'll put that back up. So now 9R cubed equals 576.
Mhm.
Why am I doing that? I don't want to do long division. $64. So R equals 4, yes?
Yeah.
Okay. Okay, so we need U sub 1, right?
Mhm.
So then we know that what? We can plug in here, yes?
Mm.
So all right, 4U sub 1.
So U sub 1 is equal to 3.
Yeah. All right, so now S sub 5 is equal to U sub 1, 3 times what's stupid R? 4
to the
cubed,
power of 4. Oh,
4 cubed,
isn't it?
4 to the 5th. Wait, what?
Yeah, isn't it 4 to the power of 4?
What's the first 5 terms?
Oh, you're doing the sum. I thought. Okay, my bad. That would be easier. Yeah.
4 to the 5th minus 1 over 3. 4 minus 1 equals, I don't know. Well, this goes away, right?
Mhm.
3 over 3,
Oh,
right?
yeah.
4 cubed is 64. 2 times 4, 2, 4, 256 times 4 is 256 times 4. 4 times 250 is 1,000. 1024. So it equals 1020. What the hell? Okay, 1024 minus 1, which is 1023. I got a message that was weird. That's why I said, what the hell? Okay. How we doing?
Yeah, that makes sense.
Okay. All right. So, ooh, doctor. Okay, so first of all of the 3-digit numbers are 100 to 100 or to 999, right?
Yeah.
Okay. Um, and the divisible one, divisible by 3. What's the smallest divisible by 3?
Like the smallest number in that range.
Yep, because that's all we're considering, right?
Yeah. Is it 101?
Do you know the divisible by 3 shortcut?
No.
Okay, 372. It is divisible by 3 because the sum of its digits, 3 plus 7 plus 2 is 12. And 12 is divisible by 3. So if the sum of the digits of any number is divisible by 3, then the number itself is divisible by 3. 9, 7, 5, I don't know, 4. 16, 21,
117. Oh,
16, 21, 25. Nope. Right?
yeah.
But if I did 6, 16 plus 11 equals 27. Is 27 divisible by 3? Do you trust me or do you want to check it?
9 threes is 27.
No, no, 9756. Jesus, Vaish. You don't think I know?
No, I trust
You
you.
want to check? Yeah, hold on. 27. Yeah. 9 times 3 is 23, Dave. So, yep. So 9756 divided by 3 is 3252. How about that? Now you can do the same thing for 9 because 9 is a multiple of 3.
Mhm.
So if the sum of the digits are divisible by 9, the number is divisible by 9. Okay. So what is the smallest number divisible by 3?
111. Oh, yeah, that works too.
What's the next one?
108.
Dude, add 3.
What? 105. And then 108.
Oh, yeah, okay. I see what you did there. Okay. So they only want the sum of all 3-digit natural numbers that are not divisible by 3. So they want the 101 or the 100, right? 101, 102, 103, 104, these guys, right?
Yeah.
Boom, 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 boom. The problem is these guys don't form anything, any sort of sequence. We could come up with a formula, but who wants to do that? To generate the sequence, but not the sum. So we're not going to do that. So do you have any ideas on how we could do this using your excellent brain? And let me know if you want a hint.
Can I get a hint?
Can we find the sum of these numbers? I should go out to here.
Yes, we can. And then you can subtract it from 990, not from 8, not 8, 9 from
I need the sum of these numbers, right?
Oh, you can find the sum of all the numbers, and then from that you can subtract the sum of those numbers.
Yes. So sum of all, and all of them form a geometric or arithmetic sequence, don't they?
Yeah.
Minus sum of div 3. See what I did there? How about that? Div 3.
Oh, yeah.
Yeah. Okay. All right. What you want to do now?
I guess we can just start with the easy part, which is just the sum of all of the numbers.
Okay. So what do you want to do?
So we can just use the sum formula.
Okay.
And then we can
Which one?
The second one.
Good. So S sub n. Oh God. What are we gonna do?
Is it 900?
Justify it.
Because 899 plus 1.
Now, how did you think that through? That's impressive.
Because my dad taught me that a while ago.
Stop crediting your dad.
I
Oh, there he
learned
is. Oh, did he just hear
that by
me?
myself actually a while ago.
Is he there? And he just heard me say that?
Yeah, he heard
Okay.
me.
So okay, so it's the number of numbers, right? When you're finding the number of numbers, you have to add, yes, okay. So the sum of the first 900, right?
Yeah.
Okay. So that,
sorry.
I'm sorry.
Sorry, I was just gonna say it.
Go.
So that is equal to 450 times 100 plus 999.
Good. Now, what about these guys?
So those also form an arithmetic sequence. So we No, so we can, I guess we can find the sum of those by, we can, I guess we can also use the second formula.
Okay, well, I'm gonna need an N from you.
So S of, mm, how many terms are there?
Well, what's the largest one that's divisible by 3?
Um, wait, isn't it 999?
Yep.
Wait, then shouldn't we not have counted 999 in the other one?
And the what?
In the sum of, oh wait, no, never mind. That's the sum of all of them. Okay, yeah.
Correct. Correct.
So we know the first term is 102 and the last term is 999, but how do we find out how many terms there are?
Well, let's see. This is use of 1, use of 2. This is use of 3. Well, let me rephrase that. 1, 2, yep. 1, 2, yep. So every third one.
So
Let me ask you this. How many of the numbers between 100 and 199 are divisible by 3? Or easier, how about 0 to 99? It's the same number, isn't it?
mhm. Yeah.
Well, okay, so there's a couple ways we can go here. 102, 105, 108, 111. I'm not gonna list them all, don't worry. 114, 117, 120, 123, 126, 129. I'm just trying to give you a way to think about this, right?
Mhm.
Right. And we know the last one is 999. Right? Ends in 9. Yeah. So this iteration is going to continue, right?
Mhm.
It's going to continue because the next one is what? 132, which ends in 2. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many iterations from 102 to 129 will there be to get to 199?
999 divided by 129.
Well, it's going to go 32 to 59, isn't it? I'm sorry. I'm just trying to get you a way to think about patterns.
Mm. Mm.
Do you see how we know this is 59 because 102 to this is 27, right?
Mhm.
Right. So 132 plus 27. right? It gives me 159. And then 162, ready? Plus 27 is
189.
mhm.
So if you do 999 divided by 27, then you can see how many like times it repeats,
You could. I mean, that's one way to think about it.
and then multiply that. Wait.
The quick, you can also, you also know that 999 is the last term. Like if you're unsure about it, I think the temptation is to divide it by 3. Right?
Mm-hmm.
And then you have to cut out the 0 to 100. But we do know that, let's see, 999, the last term, I'm going to use this formula, equals the first term, 102, plus 102 plus n minus 1 times the common difference is 3, right?
Mm-hmm. Oh, and then you can just find.
What 99, right? 99 plus 3n. Oh, looky there, 900 plus 3n. So it does work, doesn't it? Yes.
Mm,
Now, also, I took a long time to get here, but shouldn't it make sense that if we have 900 terms, so
900
1,
divided
2,
by 3
3,
is
right?
every
1, 2,
word.
3, that, yes. You okay?
Yeah, I'm just thinking that makes sense. Yeah.
Okay. So now we have and this is 333. You with me? I'm sorry, 300. I was going, sorry. I started from 0. I don't know why I had 333 in my mind. 300, right?
Yeah.
Okay, so here's the first one, minus
So the 150 times 102 plus 999.
plus 999. So whatever that is,
Yeah.
I guess we should figure it out. We've come this far, right?
Mm-hmm.
All right, so do you have a calculator in front of you or no?
I don't know.
450 times.
Oh, I have my phone.
Me too. $330. Did you do it?
Yeah, that seems right.
That seems right. God.
Oh, I got like minus 9. Is it 951?
165150.
Oh. 4, 9, minus 1.
I'm like typing in numbers like lightning here, okay?
I got 329,350.
That's what I got. Yep. Good. Who knew? All right. You feel okay with that?
Yeah.
I'm glad that you were able to come up with the sum of all minus the sum of divisible by 3.
Mhm.
That was the main thing I wanted you to be able to do, is see that. Okay.
Mhm.
All right. Let's see what else we got. These are really cool questions, by the way. I like them. This is a long question. Ooh, it's a section B question. I love it. Let's see what happens. Do you know oh, you're a junior, so you might not have heard yet. On your IB exam, there's a section A and a section B
I did not know that.
on each paper. Well, not on paper 3. The syllabus changed for me and I forget exactly what paper 3 is. I know what it used to be, so I'm not going to comment on paper 3 yet. Paper 1 is non-calculator. There's a section A and a section B. Section A is short response, usually an average of 6 marks each. And then section B is 3 questions worth anywhere, it just depends. But like this is section B where it's 22 marks, this one question, right? And your species, meaning IB candidates as a species, get freaked out when they see, oh my God, all these questions, right? But all it is a series of short response questions. That's all it is. And I haven't read this one yet, but almost always IB is leading you through, right? In order to answer question B, you need question A. And a lot of the time it's show that P minus 2 is a solution to the equation. Boom. Right?
Mhm.
So even if you can't show that P equals 2 is a solution to this, right?
Mhm.
Then you're able to do the next one. Because you need that to do this or whatever.
Yeah.
Okay. All right. So A, P sub 3, and don't you really want to say P cubed, right? Plus P sub 2 minus 5P minus 2 equals 0. I did 5 sub P, it's 5P. What you thinking?
Not much.
Let me go back here. I'm looking back at the question. Hold on one sec. Not thinking much.
Yeah.
Well, what if we plugged 2 in?
I guess we could do
Or is there another way?
so I guess then it would be like piece of 3 plus piece of 2 minus 22.
Minus 12.
Oh. Oh, yeah, minus 12.
Ooh,
So
hold on.
piece of-
I'm sorry. Yes, sir. Hold on. I'm sorry, security is roping off this area and they're asking me to leave
oh,
at the airport. I'm not sure. Yeah, I have to go. I'm sorry.
okay.
I will try and work on the plane and send you a solution for this. I'm sorry. Yeah, and do it that way
Okay.
if I can.
Thank you.
Sorry.
It's okay.
All
Thank
right.
you.
Bye.
Bye.